Right now, as you are watching this, a Super El Niño pattern is actively reshaping the weather across multiple continents at once. The Eastern Pacific just recorded ocean surface temperatures running more than 2 degrees Celsius above the long-term average, a threshold meteorologists reserve for only the strongest events ever measured. Parts of Peru and Ecuador just logged rainfall totals that would normally take an entire season, dumped in a matter of days. The Asia-Pacific Rim recorded a record-setting heat spike weeks ahead of when peak heat should even begin. The World Meteorological Organization published an update this month, saying the odds of this event ranking among the 3 strongest on record have climbed sharply. In North America, Southern Africa, and parts of Australia were all flagged for abnormal pressure shifts in the same week. This is not normal seasonal noise. Something significant is happening across the entire global weather machine simultaneously. Today, we are going to break down exactly what is going on, where it is most dangerous in the coming weeks, and whether things could get even worse before they get better. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever personally lived through a winter or a summer that an El Niño made unrecognizable? Floods where there should have been drought, or drought where there should have been rain? Tell me where you were and what it felt like. If you want to be the first to know every time something major happens with our weather, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Now, let us get into it. To understand why forecasters are worried, we have to start with a date. On June 11th, 2026, ocean buoys strung across the equatorial Pacific began reporting a sustained warming signal that had been building quietly for months. By late June, sea surface temperatures in the NEO 3.4 region, the patch of ocean meteorologists watch most closely, had crossed 1.5 degrees Celsius above average, the official threshold for a strong El Niño. Within 3 weeks, that number kept climbing instead of leveling off, something forecasters do not expect to see this early in a developing event. By July 9th, readings had pushed past 2 degrees Celsius above average in isolated pockets. Numbers that put this event in the same conversation as 1997 and 2015, 2 of the strongest El Niños ever recorded. The atmosphere responded almost immediately. In the second week of July, Peru's northern coastal region recorded over 300 millimeters of rain in a 72-hour window, an amount some towns normally see across 4 months combined. Rivers that had been dry for years suddenly carried enough water to wash out sections of the Pan American Highway. Officials in Piura declared a regional emergency on July 14th after floodwater displaced more than 6,000 people in under a week. On the other side of the Pacific, the signal flipped. Indonesia and parts of the Philippines, which normally rely on El Niño years for slightly drier conditions, instead recorded rainfall deficits severe enough that agricultural officials in Java began warning about rice yield stress by the 3rd week of July, months earlier than officials typically issue that warning. Meanwhile, Australia's Bureau of Meteorology flagged an unusually rapid drying trend across the country's eastern grain belt, the exact signature seen before Australia's worst El Niño-linked droughts. North America felt it differently. In the first 2 weeks of July, the jet stream that normally guides weather systems across the continental United States began shifting further south than models had predicted even 30 days earlier. That shift dragged an unusually persistent ridge of high pressure over the central and southern plains, and by July 18th. More than 40 million Americans were under some form of heat advisory simultaneously, a number that would typically not appear until deep August. Temperatures in Texas, Oklahoma, and parts of the lower Midwest sat between 8 and 14 degrees Fahrenheit above normal for stretches lasting a full week or longer. To put that in context, a persistent ridge like this is not a single hot day. It is the atmosphere getting stuck, the same weather pattern locking in place over one region for days or weeks at a time, instead of moving through the way it normally would. That is exactly the kind of stuck pattern strong El Niño years are known to produce. And it is exactly what is unfolding right now. But here's the part nobody expected this early. Several independent forecasting centers, including NOAA's Climate Prediction Center, quietly revised their intensity outlook in the second week of July, moving this event from the strong category toward the boundary of very strong. A distinction that matters enormously, because very strong El Niños are the ones historically tied to the most extreme and most costly weather disruptions on record. To put the speed of this development in context, The 2015-16 El Niño, one of the strongest ever measured, took roughly 5 months to climb from the 1.5-degree threshold to its eventual peak near 2.6 degrees. This event has moved from onset to a 2-degree reading in under a month, a pace that has caught the attention of ocean modeling teams at multiple national weather agencies, some of whom flagged the trajectory as an outlier worth extra scrutiny in internal briefings released in mid-July. Satellite altimetry data, essentially a measurement of how much higher the ocean surface is bulging compared to normal, showed the equatorial Pacific sitting several centimeters above its typical height by July 15th, a physical signature of just how much extra warm water has piled up along the South American coast. That bulge is not a curiosity. It is the direct fuel source for the coastal flooding already unfolding in Peru and Ecuador, because warmer water evaporates faster, loads more moisture into the atmosphere above it, and that moisture eventually has to come down as rain. Now let us get into the mechanism, because understanding why this happens is what separates real risk from headline panic. El Niño is not, at its core, a storm. It is a shift in ocean temperature that reorganizes the entire global atmosphere. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, piling warm surface water up near Indonesia and the western Pacific, while cooler, nutrient-rich water rises up along the coast of South America. That temperature difference between the warm west and the cool east is one of the primary engines that organizes weather patterns across the entire planet. During an El Niño, those trade winds weaken, and in a strong event, they can briefly reverse direction altogether. Without the winds holding it in place, the warm water that is normally stacked up in the west sloshes back across the Pacific towards South America. To put that in context, we are talking about a pool of warm water covering an area larger than the continental United States, shifting thousands of miles east over a period of months. That relocated warm water becomes a massive source of heat and moisture, and the atmosphere above it responds by shifting where it rises and where it sinks. Thunderstorm activity that normally sits over Indonesia and the western Pacific migrates east toward the central Pacific. That single shift reorganizes the jet streams across the entire globe. The high-altitude rivers of air that steer storm systems, heat domes, and cold fronts nudge the jet stream even a few hundred miles, and entire continents experience a completely different season than they were expecting. Scientists measure the strength of this shift using something called the Oceanic NEO Index, a rolling 3-month average of those NEO 3.4 temperature readings. Anything above 0.5 marks a weak El Niño. Above 1.5 marks strong. The version building right now has already brushed past 2 degrees in weekly readings, which is the range where the index starts overlapping with only a handful of events in the last 75 years of record keeping. If the 3-month rolling average confirms that level once August data comes in, this would rank among the 4 strongest El Niños since reliable satellite and buoy monitoring began in the late 1970s. This is why El Niño's fingerprints show up almost everywhere at once, even though the actual temperature anomaly is confined to one strip of ocean. Peru floods because the warm water and moisture are now sitting almost directly offshore. Indonesia and Australia dry out because the rising, rain-producing air that normally sits over them has migrated away. The southern United States tends to see a wetter, cooler winter later in the cycle, while the jet stream shift earlier in the year can lock in the kind of stubborn summer heat ridge we are watching build right now. None of this is random. It is the direct, physically explainable downstream effect of one patch of ocean running 2 degrees too warm. And the stronger the ocean anomaly, the more forcefully it pushes the jet stream out of its normal lane, which is exactly why forecasters pay such close attention to how fast and how far these ocean temperatures climb in the early months of a developing event. These are not just numbers on a chart. They are human experiences playing out in real time on opposite sides of the planet. In Piura, Peru, families who had rebuilt after the catastrophic 2017 coastal El Niño floods watched the same rivers rise again in July 2026, this time with less warning, because the event intensified faster than typical seasonal models anticipated. Local reporting described residents wading through waist-deep water to reach relatives, carrying what possessions they could lift above their heads. Schools across 3 northern regions suspended classes for over a week as roads became impassable. Contrast that with Central Texas, where the danger arrived without a single drop of rain. A prolonged heat ridge does not look dramatic on camera the way a flood does. There is no wall of water, no dramatic rescue footage. Instead, there is a slower, quieter danger. Emergency rooms in Austin and San Antonio reported a measurable rise in heat-related admissions during the third week of July, concentrated heavily among outdoor workers and elderly residents without reliable air conditioning. The difference between a flood disaster and a heat disaster is not luck. It is visibility. And visibility is exactly why heat consistently kills more people in the United States every year than any other weather hazard, while receiving a fraction of the media attention hurricanes and floods receive. Meanwhile, in parts of rural Java, farmers who timed their planting around a normal El Niño year, expecting a manageable dry stretch, are now facing a deficit sharp enough that some agricultural economists are warning of the earliest rice stress signal in over a decade for that region. There was no singular warning moment, no siren, no evacuation order, just week after week of rain that simply did not arrive on schedule, compounding quietly until it became a food security conversation. There is a third contrast worth sitting with, one that rarely makes headlines at all: the fishing communities along Peru's coast that depend on the cold, nutrient-rich Humboldt Current for their livelihood. As warm water displaces that cold current anchovy populations, the backbone of Peru's fishing economy, collapse almost overnight. During the 1997-98 event, Peru's anchovy catch fell by more than 80% within months, and early reports from fishing cooperatives in July 2026 describe a similar pattern already beginning. That is not a dramatic flood image, but for tens of thousands of families it is the difference between a normal year and a year without income. These are not disconnected local stories. They are the same global mechanism, expressing itself through completely different disasters depending on which side of the reorganized atmosphere a given region happens to sit on. So what happens next? Keep an eye on the ocean temperature trend line first, because it is still climbing and has not yet shown the plateau forecasters usually look for around this stage of a developing event. If readings keep pushing upward through August, several forecasting centers have indicated this could formally be classified among the strongest El Niños of the past 70 years, in the same tier as 1997-98 and 2015-16, both of which produced billions of dollars in weather-related damage globally and were tied to measurable spikes in heat-related mortality. Watch the central and southern United States heat ridge over the coming weeks as well. Current model guidance suggests the pattern is likely to persist through at least early August before there is a realistic chance of it breaking down, meaning the 40 million Americans currently under heat advisories could see that number grow rather than shrink in the near term. Keep an eye on the Western Pacific dryness signal too. If Indonesia and Northern Australia continue trending drier through the next several weeks, agricultural officials in both regions have indicated they may need to issue formal drought declarations earlier than in any previous El Niño cycle on record. There is also a secondary signal worth watching that most coverage of this story has missed entirely. The stratospheric wind pattern known as the polar vortex configuration tends to respond to very strong El Niño events with a delay of several months, which is part of why forecasters are already looking cautiously toward the following winter, even while this summer's story is still unfolding. If the current ocean warming holds through autumn, several long-range outlooks suggest an elevated chance of a more volatile winter pattern across parts of North America and Europe, though officials are careful to stress that this remains a probability shift, not a certainty. And pay attention to what happens along the Peruvian and Ecuadorian coastline specifically. Historically, the most extreme flooding damage from a strong El Niño does not arrive at the very beginning. It tends to peak several months into the event, once ocean temperatures near the coast have had time to fully saturate the atmosphere above them. If this event continues intensifying at its current pace, meteorologists are watching closely for the possibility that the worst of the coastal flooding is still ahead rather than behind. None of this means catastrophe is guaranteed. Scientists generally do not conclude that any single El Niño will automatically become the most damaging on record. And there is currently no scientific evidence that this event will exceed the historic extremes of 1997 or 2015. What the data does show, clearly and without exaggeration, is a fast-developing, still intensifying pattern that has already crossed thresholds significant enough to warrant close monitoring across multiple continents at once. So let us bring this back to what actually matters for you. The version of the story that spreads online is that a single monster El Niño is about to unleash unprecedented global chaos all at once, tomorrow, everywhere. That is not accurate, and it is not how these events work. The real, evidence-based picture is calmer, and in some ways more useful, because it tells you exactly where to look. The ocean anomaly driving all of this is not slowing down, and multiple forecasting centers have real reasons to be watching it closely through August. But the most realistic near-term danger for most people watching this in North America is not a single dramatic event. It is the quieter, slower-moving heat ridge sitting over the central and southern United States right now. The kind of pattern that does not make for dramatic footage, but that public health officials consistently link to more heat-related illness and death than almost any other weather hazard we track. If you take one thing away from this, let it be this. Watch the heat advisories in your own region over the coming weeks, check on elderly neighbors and relatives, and take a persistent heat ridge as seriously as you would a storm on the radar, because history shows it deserves exactly that level of attention. Drop a comment and let me know. Has your region felt the effects of this pattern yet? Unusual heat? Unusual rain? Or has it been quiet where you are so far? Let us go for 5,000 likes on this one so more people see the real, evidence-based picture instead of the panic version. Let us go. See you in the next one.